Good evening, week 12, Tuesday. We're going to continue on our shaft design, and quiz number 4 will be available on July 21st, and it's going to be from homework 10, and homework 10 is regarding Mohs circle. Okay, so your quiz will be based on Mohs circle. You can collect your term test this Thursday. So today is the 19th. Can collect term test 2 on July 21st at ETB 216, which is outside my office. So we are going to continue on this example that we did last week. So just to briefly recap what happened last week, we look at a shaft design. Okay, we look at a shaft design, and the objective of this example is to choose the minimum size of the shaft AB, given that the shaft is rotating at 480 RPM and the motor input to the system is 30 kilowatt, and gear G is taking up 20 kilowatt, gear H is taking up 10 kilowatt. The stress allowable for the material used for the shaft is 50 megapascal. We're going to determine the smallest diameter of the shaft AB. So we did calculate the forces acting on gear C and gear D and gear E. So I'm going to start by, so the next thing that we're going to do, which I'm going to continue on with today's lecture, is we have to determine the reactions at point A and point B. And if you look at the shaft, the point A and point B are used for ball bearing. Okay, so these are bearing housing. Okay, so we are going to determine direction at point A and point B. And with these forces, you can also do sizing of your bearings. Okay, but I'm not going to do that. This course is not about sizing, selecting of bearings, more on stress analysis. Okay, so we're going to determine the reaction at A and B. And like what I've taught you before, we are going to look at this in a 2-view world. Okay, like how I taught you guys on compound loading. So first, we are going to view based on the transformation. We're going to view the structure in the XY plane and rotation about Z. Okay, so we're going to draw our sketch, our shaft. Okay, so this is our shaft. This is our point A, point B, point C, point D, and I believe that this is our point E. And then we have our neutral axis. Okay, so we are aware, looking at the forces, right? At point E, you have 3730 coming down. Okay, so at point E, you have 3730. And at point C and point D, you have forces going into the shaft or into the paper. This is sitting at 6632. And then you have another one at 2847. Sorry, 2487 Newton. So from here, we are going to calculate the reaction in the y direction at point A, which we call AY, and then we're going to do BY. Okay, so we're going to apply static analysis. Now we only determine the forces that are not, or we're only considering the forces that are the full arrow, not the dots and crosses like how I teach you in compound loading. Okay, so we are going to do summation moment about a z-axis at point A. The whole thing is equal to 0. So we have minus 3730 multiplied by the distance of 0.6 and then plus by 0.8 by. The whole thing is equal to 0. So by is equal to 3730 times 0.6 divided by 0.8, which is 2797.5. Okay, and it's positive, means going up is correct. Now, before I go any further, what are we trying to do down there? Is we are trying to determine, okay, before I go on, I know we are looking for direction. Our objective, yeah, maybe you guys forget, our objective is to determine the most critically loaded position of the shaft. Okay, so just to recap, so we're going to determine the most critical loading position of the shaft. So it can be at point C, it can be at point C, point D, and at point E. And the criteria will be based on, so you all remember this function, right? Where we have my squared plus by mz squared plus by tx squared. Okay. So if that function my squared plus mz squared plus tx squared is the largest, okay, that's where the size of the shaft is going to be controlled by that position. Okay, so we don't know is it C, D, or E. Okay, so you can realize that this function over here is there are two moments, one in the y and one in z, and the torque is in the x. So now we are finding the reaction, okay, to determine the moments. Okay, that's where we are now. Okay, I repeat again. We are going to determine we are going to determine the reactions, then we can calculate the moment. Okay, so this is where we are. Okay, so we apply static analysis, moment with z. We found that by is equal to 2797. Then you can have summation of forces that's going up in the y direction is equal to 0. So this is equal to ay minus by 3730. Let me write minus 3730 plus by 2797.5. The whole thing is equal to 0. So from here, ay is equal to 3730 minus 2797.5, which is equal to 932.5. And is going up. Okay. Then we have to find the reaction in the z direction. Okay. So from here, we're going to change the view. We're going to view x in this way now. And this is z. And this is rotation about y. Okay. So we're going to view it so-called the plan view. Okay. So I'm going to draw the sketch the shaft. the neutral axis. Then again, point A, point B, point C, point D, and point E. And the forces that we know, okay, we have 6632 going up in this direction. Okay, so this is your 6632 Newton, and you have 2487. So we know that we are going to have a By, and we are going to have Ay. Okay. So again, we're going to do static analysis, right? So summation of moment in the y direction at point A. Okay, the whole thing is equal to 0. So you have 6632 multiplied by 0.2 plus by 2487, because they are all going in the anti-clockwise direction. Multiply 0.4, 2468. Then you have minus 0.8 By. Okay, you have 0.8 By. The whole thing is equal to 0. So we calculate Dy is equal to 6632 times 0.2 plus by 2487 times 0.4 divided by 0.8 is equal to 2901.5. Newton, and it's coming in this direction. Is correct, right? It is correct because it's positive, right? If it's negative, then we need to flip the direction. Okay. Then we have going up is positive. Dimension of forces in the z direction is equal to 0, right? So you have minus Ay plus by 6632 plus by 2487, then minus 2901.5. The whole thing is equal to 0. So we have Ay. Sorry, this is not y. This is z. My apologies. Okay. So this is Az, Bz. Okay. All this I'm calculating is z. Z, and we're calculating for Az. Okay. So Az will be equal to 6632 plus by 2487 minus 2901.5 is equal to 6217. Okay, 6217.5. Wait, did I do anything wrong? 6632 2487 minus by 210. 6632 2487 minus 2901.5 is equal to 6217. Okay, I got 6217.5. And it's positive. It's going up. So now we have got our reaction at point A, and we also have our reaction at point B. So we're going to put the reaction into this diagram over here. Okay, I'm going to copy and paste the diagram again.